To the point, informative, entertaining, and protecting the Second Amendment, welcome back to Elfster's Rifles and Reloading, in part 2 of this Elfster's 101 series. Now in part 2 here, my main objective is just to concentrate on what and how to use minute of angle and mil based scopes. Now this is a lot of information to take in. So if you are new to the game, you might need to watch this several times to let it absorb. And even if you've been around the block a few times, you might learn a thing or two. But I'm going to try my level best to explain this to you in a fashion that your average Joe can understand. Now before we get neck deep into what and how to use minute of angle and mil based scopes, there's just a few things I need to go over. Now there are a lot of variables that affect your bullet's trajectory. It's too many to list actually, but there is one constant you can rely on, and that is gravity. It's dependable and it's repeatable, but there are other variables that come into account when it comes to your bullet's trajectory. Now those variables are numerous, but if I had to pick one, the biggest variable that affects your bullet's trajectory would be obviously wind. And I know for some of you guys that are veterans, this seems pretty obvious, but if you're new to the game, wind is the #1 factor. I'm not going to be totally going over wind in this part of the series in regards to how to combat that variable, but it's something to keep in mind, and I plan on hitting that eventually later in the series. The other variables that you have to take into account in regards to your bullet's trajectory can be numerous. It could be elevation, temperature. It can be also your own shooting, whether you're pulling the trigger correctly or your reloads. If you might happen to have a little bit more powder in comparison in one cartridge in comparison to the next, that bullet is going to impact paper higher than the other. Even such things as simple as neck tension. If one piece of casing has tighter neck tension than the next, that one with tighter neck tension is going to build up more pressure. It's going to have more velocity. It's going to impact your target at a higher elevation. Other things as you're shooting your rifle, as your barrel gets fouled, that can also affect your barrel's trajectory. Some barrels like to be shot clean, some like to be shot dirty, some are in the middle, and that can affect your bullet's trajectory. There's so many variables that come in to how your bullet flies through the air as it exits that muzzle. It's too many to list. Even some things as the earth spinning on its axis at 1,000 miles an hour can affect your bullet's trajectory. I'm not going to be totally going over the Coriolis effect in this part of the series, but this might be something to Google and do more research on, especially if you're shooting past 1 mile. Other things such as bullet spin drift, how the bullet can spin off into the direction that the projectile is rotating as it comes out of that bore's rifling. There's so many variables that come into play when it comes to your bullet's trajectory. Like I mentioned earlier, it's too many to list here. But in this particular section, we are going to be concentrating on just gravity and what and how to use minute of angle and mil based scopes. Now before we get neck deep in MOA and mil based scopes, there's something I just want to get out of the way. And how do you guys like my cheesy rifles here? This is about the extent of my artwork. But anyways, just to get something out of the way, and like I said, I've actually run into a few people that actually think when they shoot their firearm that the trajectory of that bullet does something like this. Or something like magically goes up and then goes down, or some BS like that. And that is way wrong. That doesn't happen. There is something called the line of departure, and that is if you could create the vacuum of space and shut gravity clean off, that projectile would follow a straight line. It never does this. One nice thing about gravity is it's dependable and it's repeatable. And there's one thing you can always count on that projectile to do, is the second it leaves the muzzle or the end of that barrel, that bullet is going to drop. And I mean the second it leaves the muzzle. It's not noticeable right away because obviously that bullet is traveling so tremendously fast, but it's something like that. And it just depends on numerous things. The length of the barrel, which affects the bullet's velocity. How much powder you put behind that bullet, that can affect the bullet's trajectory to go even further. You're shooting a completely different rifle, say something from a 223 to a 300 Win Mag. Obviously, it's going to have a further distance that bullet can travel. And that's something you got to keep in mind. And it never does this, and it never goes above the line of departure. Now, when you do something like 100-yard zero, I'm going to draw a really faint line here for the line of departure. See if you guys can see that in the video. Yep. Okay. And for pure example, this is your bullet's trajectory. Remember, it's dropping the second it leaves the muzzle. So it's something like this, and I'm going to exaggerate it. So something like that. And what happens is the difference between your rifle's bore and your scope for something like this. Now this would be something, for pure example's sake, like a 100-yard zero. This is called the line of sight. Now this is somewhat exaggerated, but I'm doing this just to demonstrate to you what's going on here. Now, for pure example's sake, this would be very typical for a 100-yard zero. Say like you had a steel gong here at 100 yards and you zeroed it at 100 yards. So lock that in your brain. The bullet's trajectory is never going to go past or above this line of departure. Although it appears like it's climbing, the bullet is always dropping the second it exits the muzzle. It is climbing in regards to the arc or the path of that bullet's trajectory, but it is always dropping. Now, for pure example's sake, if you do have a 100-yard zero and you're out hunting and the deer is ultra close, say for example 25 yards, you better make sure you aim a little high. And that's the reason why, because that bullet, when it leaves the muzzle, it's still climbing, and you may need to make up that difference. Now you can have multiple zeros. Now I'm really going to exaggerate this. Now it's never really this bad, but just to get my point across, some rifles, especially like short barrel rifles or maybe like an AR-15 with iron sights, you might want to set it up with something like a 25-yard and 300-yard zero. You can see what I did. I intersected the bullet's trajectory with the line of sight so close that the trajectory's arc actually has two intersections of the line of sight. The bullet's trajectory intersects the line of sight at 25, and it arcs up and arcs back down at 300 yards. And a typical reason why you do this, you'll see this a lot in the military, they want to do this so regardless of where they're shooting, 100 yards to 300 yards, they don't have to do any holdovers. They can just put their iron sights or their red dot on the target and pull the trigger. The difference between the line of sight and the top of this arc between 25 and 300 yards might only be a couple inches, but in regards to minute of man, it doesn't really make that much of a difference. So you can actually have one zero, and you'll typically see this 100-yard zero for, you know, long distance rifle shooting, you'll typically have a 100-yard zero, or if you have something more like a close quarters combat situation, you might have a multiple zero where it's 25 and 300 yards. And this is completely dependent on the cartridge that you're shooting and that bullet's trajectory. Now, for pure example's sake, ignore the 25 and 300 yard zero and concentrate on the 100. Say like your rifle and your scope is set up for a 100-yard zero. Well, now you want to go shoot at 500 yards and your steel gong is more down here. So what's going to happen is you're going to adjust your reticle up, which actually forces your reticle to go down, and it forces you to pitch your rifle at a slightly higher pitch. And let's try and draw this in as best as I can. What's going to happen is you can see that old trajectory is going to take a whole new trajectory, and you're going to do something more like that by adjusting the reticle on your scope or doing a holdover. But you can still see that that bullet never goes above the line of departure. I just created a whole new line of departure. So if you were sleeping in science class, your bullet's trajectory never does this. Now, before I go any further down this video rabbit hole with you guys, and we go over my ballistics calculator, and I try to help you decide which optics and mount to get, which you prefer to get based on your firearm's purpose, there is one big fat white elephant in the room that I need to get out of the way, and that is to explain to you what is minute of angle and what is MRAD, or also known as mils or milliradian, whatever. Both of these scopes are identical. They're both Vortex Viper PSTs with a power range from 4 to 16 magnification. They both have a 50mm objective. The side focus or parallax adjustment is on the side with illumination knobs here. They're both identical. The only difference between these two is this one is minute of angle and this one is mils. Now, I'm asked this question a lot. Which one is better? Which one should I go with? Should I go with a minute of angle based scope or a mil based scope? And there really is no right or wrong answer. You really can't go wrong with either a mil or MOA based scope. They're both equally effective, and it comes down to how well you know the system. And that is the reason why I like to keep a collection of both minute of angle and mil based scopes in my collection, so I can stay fresh with how these perform out in the field. And that is another reason why I recommend getting both a minute of angle and mil based scopes in your collection. And once you learn the method to their madness, you'll come to understand that the differences between these two scopes is very minor. Now, I see this all the time on forums and in closed groups on Facebook. You know, someone will mention, you know, if you think in yards and inches, the math for range estimation is easier with MOA. And if you think in regards to meters and centimeters, the math is easier with mils. And there is some slight truth to that, but overall, in my opinion, that is a bunch of bullshit. Now, don't worry, I'm about to explain what is minute of angle and what is mil on paper. But just to let you know, this is a minute of angle scope with 1/4 minute of angle adjustments on the turret. So if I make one full minute of angle adjustment, it takes 0.25 or 1/4, 0.5 or 1/2, 0.75 or 3/4, and one full minute of angle adjustment. On the other hand, when it comes to the mil based scope, to make one full mil adjustment, these adjustments are in 0.1 or 1/10 of 1 mil. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1 full mil adjustment. If this piece of paper makes sense to you and you think you can't use a mil-based scope because you don't think in regards to something empirical like fractions, that's why that is full of BS. The MOA base scope, like I just mentioned, this is in 1/4 minute of angle adjustments. So for each click on the turret, you're going to make a 0.25 or 1/4 minute of angle adjustment. Another click, at 2 clicks, I'm going to make another 1/4 minute or a half, 0.5 or half minute of angle adjustment. 0.75, 3/4, 1 full minute of angle adjustment, which is 4/4 or 1.0. In regards to the mil-based scope, it really is no difference. Just because you think in regards to fractions, you can still use this. It really has nothing to do with Germany, the Autobahn, kilometers, brats, centimeters, kilometers. It really has nothing to do with that. Just because you live in America and you think in fractions, you can 100% use a mil-based scope. Rather than using 1/4 minute of angle adjustments, you're using a mil-based system, which 1 full mil adjustment is broke down into 1/10 or 0.1, 0.2, 0.3, all the way up to 1 full mil adjustment. So just because you think in fractions that you can't use a mil-based scope, that's why I think that is complete BS, and I'm going to explain that in further detail here in a little bit. There's also something I really want to get out of the way, regardless if you're using an MOA or mil-based setup like this. This has nothing to do with making inch or centimeter adjustments between these two. All you're doing is making an angular adjustment on these turrets. You are not making a 1/4 inch adjustment when you're making 1 click, for pure example, on this MOA based scope, and you're not making a centimeter for sure adjustment when you're making 1 click on this mil based scope. You are making angular adjustments that transpose to different measurements at different yardages or meters, whichever one you want to use. And I'm about to explain that in further detail. So don't let mils deter you just because you think in regards to fractions. If I give you 1 dime and I give you another dime that's 20, I give you another dime that's 30, I give you another dime that's 40, I give you another dime that's 50, I give you another dime that's 60, I give you another dime that's 70, I give you another dime that's 80, I give you another dime that's 90, and I give you another dime, you got 1 full dollar. So think that way. You're not making measurements, you're breaking down 1 full mil adjustment in 0.1 or tenths of a mil per click. Now, something I want to quickly get out of the way, regardless of which system you get, make sure if you go with minute of angle that your turrets match your reticle, and if you go mil-based, that your mil-based turrets match your mil-based reticle. It's super important. They do make some scopes, for pure example, that have minute of angle turrets or turret adjustments with a mil-based reticle, and that's the last thing you want to do. And in my opinion, you shouldn't even make those anymore, but they do. So keep an eye out for those, especially if they're an older scope. Now, one minor difference between these two is, for example, with the 1/4 MOA adjustments, they are slightly more precise than a 1/10 mil adjustment, but you really can't shoot the difference between these two. For pure example, at 100 yards, if I make 1 click on this MOA turret, that 1/4 minute of angle adjustment at 100 yards is 0.262 inches. If I make one click adjustment on this mil base scope, or 1/10 of a mil adjustment, at 100 yards, that transposes to 0.36 inches at 100 yards. Well, if I subtract 0.262 from 0.36 inches at 100 yards, the difference between those two is 0.098 inches at 100 yards. And that is less than half of the width of a 22 LR bullet. And it's not many people I know out there that can shoot that difference. So it really isn't something to be concerned about. And if you are concerned about that, especially if you're something like an F class or bench rest rifle shooter, they do offer minute of angle adjustments in 1/8 MOA adjustments per click. And they even offer in a mil base scope on your turrets 0.05 rather than 0.1 adjustments. So it's really not something to be concerned about at all. Now, if you're out at the range with a friend and you're both used to using, for example, minute of angle scopes, and you're talking between each other, you might want to go with a minute of angle scope. But I would say around 90% of the pros, for example, the PRS circuit, someone is spotting for you, they're calling out mil base adjustments. I would say over 90% of those out on the PRS circuit are using mil base scopes and reticles and spotting scopes, and that is a good reason why I think you should get at least one mil base scope in your firearm collection if you're used to using minute of angle based scopes. And it definitely doesn't hurt, and trust me when I say this, when you get used to using it, it is very easy. So just a quick overview: minute of angle with 1/4 minute of angle adjustments, 1/4, half, 3/4, 1 full minute of adjustment. On the other hand, with the mil base scope with 0.1 or 1/10 adjustments, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1 full mil adjustment. Back to zero stop. And while I have my zero stop in perspective, I highly recommend, if you can, to set your zero stop at least 1 full minute of angle below your true zero. So if this is your true zero, try to get your zero stop to stop about 1 full minute below that. Don't have it stop exactly at your zero. Why is that? Well, if you go to a different type of ammunition, or the temperature changes, or you go to a completely different area of the United States with higher altitude, you might have to drop below your true zero to get to a true zero at, for example, 100 yard zero. And that's why I'd recommend, for example, I have shims in here to set my zero stop. This is my true zero. I can't go any further past that, but at least I know that this is my true zero. So for you guys that are absolutely new to the game, I'm just going to quick show you something on my ballistics calculator. So we're going to quick reset the defaults, and we're just going to use a generic load. And this is nothing that's been chronographed. We're just going to try something maybe like a 308 Winchester. So 308 Winchester there. And we're going to hunt down a decent factory ammunition. I'm going to try something probably like Federal, probably this 175 grain gold medal Sierra Match King's boat tail hollow point. So we'll try that. And you can see it kind of sets some factory defaults. Now this is not totally accurate. You know, this is completely dependent on barrel length, especially if you're reloading, how hot you're doing the powder charge. But for pure example's sake, this is going to set the muzzle velocity at 2600. The bullet grain weight of 175 grains. The bullet diameter is 0.308 inches. Zero range, you know, typically if you're shooting something with a scope with a 223 round or higher, you're going to want to set your zero range at 100, especially with a high power scope. Sight height for something like an AR, probably going to be something about 2.2 inches, maybe 2 1/4. You know, if you want to play around with the atmospheric conditions, you can do that. This is just a pure example. Maximum range, I can play around with that. I can set it out to 1800 if I want to go to a mile. Range increments, I'm going to set that to 100. And our elevation and windage, in this pure example, we're going to start with minutes of angle. And we're going to hit calculate trajectory. So you can see at 300 yards, we're going to make an adjustment of roughly 4.5 minutes of angle. Now this is just for pure example's sake. You know, you could load up some hotter rounds and you could easily get that minute of angle below 4 minutes of angle, but this is just an example. But at 300 yards, it's dropping 14.09 inches, and that at 300 yards represents 4.49 minutes of angle. So at 300 yards, you're at 4.49 minutes of angle, and 1,000, that is dropping 403 inches or 38 minutes of angle. So this just kind of gives you a quick idea in regards to minutes of angle. So if I was to make this adjustment at 300 yards of 4.49, we're just going to round that up to 4.5 because our adjustments on our turrets are quarter minutes of angle. So we got to go 4.5 minutes. Well, you never count out clicks. So what you'd want to do is adjust in full minutes, and we got to go 4.5. So we're going to go 1 minute, 2 minutes, 3 minutes, 4 minutes, and then 0.25, 0.5. So that's 4.5 minutes of adjustment. Now, if we go back to the ballistics calculator, and I don't change anything other than changing the elevation and windage units to MRAD or mil. I hit calculate trajectory. That 300 yard measurement in regards to inches of drop hasn't changed. It's still negative 14.09 inches, but my MRAD adjustment is 1.3. So all I have to do is adjust. Let me get this in focus here. Adjust that mil base scope for 300 yards at 1.3 mils. So that would be 1 full mil adjustment and then 0.1, 0.2, 0.3. So it's only 1.3 mils of adjustment. Well, remember with the minute of angle, that was 4.5. So 1, 2, 3, 4, 0.25, 0.5. So 4.5 minutes of angle. So you can see I'm adjusting a little bit further on my turret in regards to the mil base scope, but it's really not that much of a difference. But there is a reason why PRS shooters like mil base scopes and reticles, especially on their turrets, because they adjust quicker. So let's go back to minutes of angle. And calculate trajectory. At 300 yards, we're still negative 14.09 or minutes of angle, 4.5 minutes of angle adjustment at 300 yards. At 600 yards, we're dropping negative 98 inches, and the minute of angle adjustment at 600 yards, for pure example, is 15.65 minutes of angle. So remember that. So at 600 yards, we need to make an adjustment of 15.65 minutes of angle. Well, I'm just going to round that down or up. You're pretty much right between 15.5 and 15.75. For pure example sake, we're going to adjust 15.75 minute of angle at 600 yards. Now getting back to our minute of angle base scope, we need to make that adjustment for 600 yards of 15.75 or 15.75 minute of angle adjustment. On this particular scope, one full rotation on the elevation turret is 12 minutes. You can see as it comes back around, you got 10, 11, and then when it gets one full revolution, it's 12 full minutes. So I don't even need to count my minutes to get to that 15.75. I know that one full revolution is going to be 12. So we're going to go one full revolution. I know for a fact that that's 12 minutes, and then we're going to make it 13, 14, and 15, and we need to go 15.75 or 15 3/4. So 15 1/4, 15 1/2, 15 3/4. You're done. You could take your shot. Now, when you're ready to go home and you want to go back to your zero, you just go back all the way down until you hit your zero stop. In this particular situation, it goes just below zero, and I adjust back up to my true zero. So what is minute of angle? Well, a minute of angle is just a fancy way of saying 1/60th of something. Just like there's 60 minutes in an hour, it doesn't matter really what it is. If I had a room with 60 Todd Elfers and one Todd Elfers walked out of that room into the hallway, there would be 1/60th of Todd Elfers in the hallway. I would represent 1 minute of Todd Elfers. So in regards to what is minute of angle, don't overcomplicate it. All it really is 1/60th of 1 degree. You already know what a minute is. There's 60 minutes in an hour. It's no difference with 1 degree. There's 60 minutes of angle in 1 degree. That's pretty common knowledge. What is a minute? Also, what is common knowledge, in a circle, there's 360 degrees in one circle. Well, if you were to pluck one single degree out of the 360 total degrees and subdivide that 1 degree into 60 parts, well, 1 part of the 60th degree would be 1 minute of angle. Now on paper, you're like, holy smokes, not only is 1 degree super small, but I'm going to take that little sliver and I'm going to subdivide that 60 total times into a 60th of that degree, which is 1 minute of angle. And that seems really small, Todd Elfers, on paper, which it really is on paper. But when you're shooting out to extended ranges, it makes a really big difference. And that's how you make your adjustments. So for pure example's sake, when I'm making this adjustment on my scope turret, if I can zoom in here, I make that 1 minute of angle adjustment, or 4 total clicks, I'm making that total 1 minute of angle adjustment. If I make another minute of angle adjustment or another 4 clicks, I'm going to go 2 minutes of angle. And it really is that simple, so don't overcomplicate it. And just so you know, and this doesn't really pertain to what we're doing here, but even a 60th or 1 minute of angle can even be subdivided into seconds, which is also common knowledge. You know what a second is. There's 60 seconds in 1 minute. Well, it's no different when you're working with angles. You can even subdivide this little sliver, 1 minute of angle, into 60 seconds. Well, just to give you some quick math here, I'll bring up my calculator. I'm going to zoom in here. If the circle has 360 degrees, which is pretty common knowledge, if I times that by 60, there's 60 minutes in every degree. One complete circle has 21,600 minutes. Well, I can even times that again by 60, and one circle has 1,296,000 seconds in one circle. So when it comes to mil-based scopes, it's pretty much the same thing. It's just a different way of looking at it. When you say 1 mil or 1 mil radian, that just stands for a 1/1000th of something. It doesn't matter what it is, if it's a radian, or if I have a room of 1,000 Todd Elfers and 1 Todd Elfers walked out of that room into the hallway, there would be just 1/1000th of Todd Elfers in the hallway, or 1 mil of Todd Elfers. So some other common terminology that most people know. Most people know what a radius is, or A here. You know that that is considered a radius. If it went all the way across, that'd be the diameter, but A is the radius. Well, if I take that measurement of A and I wrap it around the circumference, or B here, that is considered 1 radian. Well, if I subdivide B into 1,000 individual parts, that'd be considered 1 mil. It really is no different than this. It's just a different way of looking at it. And that's why this has absolutely nothing to do with centimeters or kilometers or Germany or bratwurst. It's just a different way of looking at it. And I hope this helps you out. So for pure example's sake, with this minute of angle based scope, when you make a 1 minute adjustment, or 4 total clicks, quarter, half, 3/4, 1 full minute of angle adjustment, remember, you are not making measurement changes at your scope. You're only making angular changes that transpose to different measurements at different ranges. Now, I made this diagram. It is an actual real-life diagram of what happens when you make a 1 minute of angle adjustment. Now, keep in mind, this isn't 2 minutes, it's not 3 minutes, it's not 4. This is just 1 minute of angle adjustment. You know, once that bullet leaves that muzzle, it's set on its trajectory. It's not going to veer off. It's not going to veer left or right unless it's affected by things such as wind. But gravity is the constant. Wind is the variable. Now, what some people do, and is fine if you're in a crunch, is they'll use what's called shooter's minute of angle. And they'll usually round down these numbers. So rather than using these complicated, for example, 1.047 or 2.094 or 3.141, they'll round these down to just 1 minute, or I'm sorry, 1 inch, 2 inches, 3 inches, 4 inches, 5 inches. So 1 minute at 100 yards would be 1 inch. At 200 yards, 1 minute of angle would be 2 inches. You can see that 1 minute of angle transposes to different measurement sizes at different ranges. So 1 minute of angle at 100 yards is 1 inch. 1 minute of angle at 200 yards is 2 inches. 1 minute of angle at 300 yards is 3. And 4 is 4. 5 is 5 inches. 6 is 6 inches. 7 is 7 inches, and so on, all the way up to 1,000, which would be roughly 10 inches. But if you do use that shooter's minute of angle, you might be fine up to about 400 or 500 yards, but you're going to start running into some errors at further distances, especially at 1,000 yards and beyond. So if I were you, I'd try to get out of that habit of using shooter's minutes of angle and use the actual representation of what 1 minute of angle is at 100 yards. Like I said before, 1 minute of angle at 100 yards is 1.047 inches. Well, if you shoot a 5-shot group at 100 yards and all 5 shots fit in a circle of 1 inch, in theory, you are sub-MOA. Even if that 5-shot group measurement was 1.03, you're still sub-MOA, because 1 true minute of angle at 100 yards is 1.047 inches. So that's really the way you need to look at it. So if you can remember just one number, this is the number I would remember: 1.047 inches at 100 yards. So where do I come up with these other numbers? Well, for pure example's sake, at 500 yards, all this number is 1.047 times 5. And I can even show you that right here. 1.047 times, 1.047 times 5, or 5 football fields, or 500 yards, however you want to look at it, is 5.235. And that is exactly what that is. So every time I make one click or 1/4 minute of angle adjustment at 100 yards is 0.262 inches. Well, one click or 1/4 minute of adjustment at 200 yards is 0.524 inches. And so on. As it goes down the line, you can see all these numbers is for pure example sake at 500 yards, one click or 1/4 minute of angle adjustment. This is just this number times 5, and that's it. And you can see that this is a cone shape. It just grows. It gets progressively worse. And that's why I say if you're going to have a precision rig, a precision firearm, if your firearm cannot group at least 1 minute of angle at 100 yards, you're going to be wasting your time down at 1,000. You know, if the best your firearm can do at 100 yards is 3 minutes of angle, well, that group, if you're trying to shoot a 1 minute of angle group at 1,000 yards or 10 football fields, it's 3 times this measurement. I'm off the screen already. So for pure example's sake, if you're trying to get the ultimate precision and shoot long range distances, if your firearm can't produce 1-inch groups at 100 yards, you're going to have a very difficult time downrange. Now, for pure example's sake, say like you're shooting at 600 yards here, and you're trying to shoot your bullseye dead center at 600 yards, and you end up shooting 6 inches low, and you're using shooter's minutes of angle, and not shooter's minutes of angle, I'm saying plural, I should say shooter's minute of angle, but say like you're shooting 6 inches low at 600 yards, you can adjust up 1 minute of angle and it should get you relatively close. But you can see if you're going for the absolute precision, you're trying to get right in the middle of that X ring, you could be potentially off 0.282 inches off. And that's why I try and get in the habit of using true minute of angle. With all that said and everything I just got done saying, some scopes are actually in shooter's minute of angle and some are not true minute of angle. And this is where you really just need to test out and track your scope out at the range. And the first thing I'll try to do with some of my precision rigs is try and track how that scope functions at distance. And it's really important, especially if you're going to go up to 1,000 yards and beyond. So getting back to the example here, if I'm shooting at 600 yards, 1 minute represents roughly 6 inches. If I shoot 1 foot low at 600 yards or 12 inches, I need to come up 2 full minutes to make up that 12 total inches. You got to think of it in blocks. You know, for example, 1 minute at 600 yards represents roughly 6 inches. At 700 yards at 1 minute represents roughly 7 inches. Well, if I'm shooting at my bullseye and I hit, for example, at 18 inches low, I need to come up 1, 2, 3 minutes of angle. Well, the same goes for your windage. So at 600 yards, for pure example's sake, I'm shooting at my bullseye and I shoot 1 foot low and I shoot 1 foot to the left. I'm going to have to adjust to the right 2 total minutes, and I'm going to adjust up 2 total minutes to get back on bullseye. And that's the way you need to look at it. So using this convenient target that has exactly 1-inch squares on it, for pure example's sake, say like we're shooting at 100 yards, you can see I got a bullet hole here, exactly at 1 inch low and 1 inch to the right. If this is shot at 100 yards, I know at 100 yards, 1 minute of angle will adjust exactly 1.047, but by using shooter's minute of angle, we're just going to say 1 inch. So I'm going to adjust 1 minute to the left or 4 clicks and 1 minute up 4 clicks to get back on bullseye. Well, the same thing goes for this bullet hole. If I'm shooting at 300 yards, I'm 3 inches low and 3 inches to the right. Well, at 300 yards, I know using shooter's minute of angle that 1 minute of angle represents roughly 3 inches. true minute of angle is 3.14, but we're just going to say 3. Well, if this is at 300 yards and I'm shooting 3 inches low and 3 inches to the right, I need to adjust left 1 minute and just up 1 minute. You can notice at 100 yards, it's exactly the same. At 600 yards, if this is my bullet hole, and I can count over 1, 2, 3, 4, 5, 6, and I need to go up 1, 2, 3, 4, 5, 6. That means I need to adjust left 6 inches and adjust up 6 inches. If this is my shot at 600 yards, I know 1 minute of angle represents roughly 6 inches if I'm using shooter's minute of angle. So I need to adjust left 1 minute and adjust up 1 minute. Well, you can see that all of these examples at 600 yards, 300 yards, and 100 yards, that they're all adjustments at 1 minute of angle. So once again, just some quick examples. Say like you took this shot at 300 yards. Well, you know, at 300 yards, using shooter's minute of angle, that 1 minute of angle represents roughly 3 inches, where you're shooting 6 inches low and 6 inches to the right. 300 yards, 1 minute is 3 inches. Well, I need to adjust left 2 minutes then, 1 minute, 2 minutes, and I need to adjust up 2 minutes also. I need to adjust up in regards to, for example, 1 minute at 300 yards, look at it as one block of 3 inches. So I need to adjust up 3 inches. Well, that's going to be 8 total clicks, or make it really quick, you're just going to adjust 2 total minutes and be done with it. Another quick example, say like we're shooting at 1,000. You know, at that point, I'd really start to use actual measurements of what 1 minute of angle represents at 1,000 yards, and that is 10.47 inches. Well, if this is my target at 1,000 yards and I'm shooting, at least with this convenient target that has actual inch squares, and if I could even see those inch squares, which probably is not the case, but you have someone telling you they're behind the berm and they can clearly see that you're shooting 6 inches low and 6 inches to the right. All you're going to do, if I take my handy little calculator here, is 6 divided by 10.47. And that means I need to adjust up 0.57 minutes of angle, and I need to adjust left 0.57 minutes of angle, which is going to be only roughly 2 clicks. And that's all it takes. You can see it starts to compound the further you shoot, especially when you're shooting long distances like a mile. And if you're curious of what this measurement is at 1 mile, well, that's easy to figure out too. You know, 1 mile is 1,760 yards. Well, I divide that by 100. That represents 17.6 football fields away. Well, we know that at 100 yards, 1 minute of angle represents 1.047 inches. Well, at 1 mile, or 17.6 football fields away, I'm going to times that by 1.047 inches, and 1 minute of angle adjustment, or 4 clicks, is going to be over 18 inches. And that's why once you start getting past 500-600 yards, you really should start using the true measurement of what 1 minute of angle represents at that yardage. And it is very important. And if you don't, you're going to miss your target. Now, using this specific Vortex Venom PST scope as an example, this has an EBR-1 MOA reticle. And say you go out to your favorite 600-yard range and you notice in front of that dirt berm that you usually shoot at is a new steel plate. It's never been there before, but you know for a fact that this steel plate is at 600 yards. Now, I have this piece of plexiglass head laying around. I made this cheesy EBR-1 reticle, at least part of it. And it's just an example of the reticle that's in this scope. But you know that this steel plate is at 600 yards, but you're not sure of the size of that steel plate. Well, being that you now know at 600 yards, 1 minute of angle roughly represents 6 inches using shooter's minute of angle, you can use this reticle to figure out the size of this plate. Now, these hash marks on this particular reticle go in increments of 2 minutes of angle. So 2, 4, 6, 8, 10 total minutes. Obviously, between 0 and 2 is 1. So we'd have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now that I just explained to you that at 600 yards, being that you know that this steel plate is at 600 yards, that 1 minute of angle represents 6 inches. So if each hash mark is 2 minutes of angle, we start out 0 here, we go 0, 2, and 4. This plate, looking through the reticle, represents 4 minutes of angle. Well, being that this steel plate, as the reticle is transposed over that image, you can tell that this plate is 24 inches wide. And the reason why you know that is every minute of angle represents 6 inches. You know, if you start out at 0, you go 1 minute of angle, that's 6 inches. You go another minute of angle, that's 12. You go another minute of angle, that is 18. You go another minute of angle, and that is 24. Simply 4 times 6, or 24 inches. So that plate at 600 yards in this particular scenario is 24 inches by 24 inches. Let's say like you take 5 shots and you impact the steel gong with a nice cluster of 5 total hits, and the center of that group is roughly 1 minute to the left and 1 minute down. You don't even need to know exactly how many inches are on the plate. You just need to know that you need to adjust your turrets, or at least adjust your reticle if you don't have enough time to adjust your turrets, that you need to come up 1 minute and to the right 1 minute. And it really is that easy. Now, just for example, say like you're trying to hit this 24 inch by 24 inch plate with a whole different rifle now, and you're way off target. You're not even remotely close. Matter of fact, you're hitting the bottom of that dirt berm, and in your reticle, you notice that the impacts are roughly in this area. Well, you can make that adjustment easily by noticing that these impacts are down 1, 2, 3, 4 minutes of angle, and they're impacting to the left 1, 2, 3, 4, 5, 6 minutes of angle. And make it really quick, just do an increment of 2, 2, 4, 6, be done with it. 2, 4, down, be done with it. Make those adjustments right on the fly. So you're going to adjust up 4 minutes of angle on your elevation, and you're going to adjust right on your windage 6 minutes, and you should hit the bullseye. I know some of you guys are really good at doing this, poking holes in paper with a pen or a pencil, but these 3 5-shot groups at 100 yards, 300 yards, and 600 yards, they're all 1 minute of angle groups, roughly, give or take, but they're roughly about 1 minute of angle in size. You know, these little squares represent 1 inch by 1 inch. Well, if I take 5 shots at 100 yards, and all 5 shots are in that 1 inch circle, the distance from the middle of this bullet to the middle of this bullet hole, you know, my pen holes aren't perfect, but say like they were exactly 1 inch apart at 100 yards, this would represent a 1 minute of angle 5-shot group at 100 yards. On the other hand, with this 300 yard 5-shot group, 1, 2, 3, 4, 5, you can notice that the distance from this bolt hole to that bolt hole is also roughly 3 inches. Well, you know from this that at 300 yards, 1 minute of angle is roughly 3 inches. It's actually 3.141, but this gives you an idea of how big this 5-shot group is at 300 yards. And this is still roughly a 1 minute of angle group. This is 1 minute. This is also 1 minute. They're just shot at different ranges. Also, when it comes to 600 yards, you know, these two bullets are probably the furthest apart, and they're also 6 inches apart. And this also represents a 1 minute of angle 5-shot group. It's at 600 yards, 1, 2, 3, 4, 5. And I'd say these are the two furthest bullet holes, and they're roughly about 6 inches apart. So all three of these 5-shot groups represent a 1 minute of angle group. And that's like what I was saying earlier. If you're going to shoot long range, you better make sure that your rifle can at least group this size at 100 yards. If it's grouping more like this, you can put another bullet hole in here for you guys, something like that. Now this is a 2 minute of angle group. And if this is the best that your firearm can produce at 100 yards, the best group it's going to produce at 600 yards is going to be twice the size. Rather than 6 inches, it's going to be more like 1 foot. So 1, 2, 3, 4, 5, 6. Let's punch a little hole right there. And, you know, let's punch a little hole over here. So if, I know some of you guys are really good at this, I'm not. But anyway, if this is the best you can produce at 100 yards, this is going to be the best you can produce at 600. So let me show you a little trick here. If you're shooting for groups, for pure example, like this new awesome 2 minute of angle group here at 100 yards, if you're trying to get a solid minute of angle size on this 5-shot group, or now 6 shots at 100 yards, and you're shooting, for example, say an AK-47 with a 7.62 by 39 cartridge. You know, it shoots the same diameter bullet as a 308. Let me show you here. So the diameter of this bullet is exactly 308. Well, I can actually zero out the calipers on this bullet diameter, and I can measure from the outside to the outside of this 6-shot group. Now, that comes out to about 1.895. Now, being that I zeroed out on the diameter of the bullet, I'm actually measuring to the center to center of the bullet hole, and that's actually how you want to do it. But measuring to the center of the bullet hole is pretty damn difficult. So what I recommend doing is zeroing out your calipers on the diameter of the bullet, measuring from the outside of the bullet hole, and that will give you an accurate measurement. So if you don't have fancy computer software to measure your groups for you, like I said, you can zero out your calipers on the diameter of the bullet, measure to the outside of your 2 furthest bullet holes, which will measure to dead center of those bullet holes. And this comes out to 1.897 at 100 yards. Well, like I've already told you, at 100 yards, 1 minute of angle represents 1.047. Well, this measurement is 1.897. So we're going to take 1.897 and we're going to divide that by 1 minute of angle, the true minute of angle, not 1, but 1.047. So that group size is actually not 1.897 in inches. The actual true minute of angle size of that group is 1.811. And I can do the very same thing at 600 yards. You know, ignore these two and go back to our original group of 1 minute of angle. And I don't know if my calipers will go that far. Yeah, it just barely makes it. Just say that that's it right there. So outside of the 2 furthest bullet holes, for pure example's sake, is 5.745, which is actually to the center of each bullet hole, being that we zeroed out on the bullet diameter. Well, 1 minute of angle times 600 yards, 1 minute of angle at 600 yards is actually 6.282. It's not 6.0. Well, if this was our 5-shot group, center to center is 5.745. We are going to take 5.745 and we're going to divide that by 6.282. Well, that group size is truly sub MOA. It is 0.914 minutes of angle in size at 600 yards. Now, on the other hand, when it comes to mils, you got to think that 1 mil radian is just 1/1000th of something. It doesn't matter what it is. In this example, 1 radian, which I've already explained to you, is broke down into 1/1000th, which is 1 mil or 1 mil radian. It's just 1,000th of something. It doesn't matter what it is. Usually in America, everyone's trying to shoot at 1,000 yards. Well, if I'm shooting at 1,000 yards, 1 mil or 1 mil radian is just 1/1000th of that. So if I'm shooting 1,000 yards, 1/1000th of 1,000 is just 1 yard. Well, 1 yard is 3 feet, or also 36 inches. So if 1 mil at 1,000 yards is 36 inches, well, 1/10 of that at 100 yards is 3.16. And that is where we come up with this number. 3.6 inches is 1 mil at 100 yards. And like I was saying before, it doesn't really matter what you're talking about. If you're shooting 1,000 centimeters, 1 mil at 1,000 centimeters would be 1 centimeter. If you're shooting, I don't know, 1,000 inches, 1 mil is 1 inch at 1,000 inches. You know, and just to make it even more ridiculous, if I was to line 1,000 Todds head to toe, 1,000 Todd Elfsters on a flat playing ground, and we were to take 1 mil or 1 mil radian of 1,000 Todds, that would be just 1 Todd. And if I was to adjust 1 mil for 1,000 Todds, you're going to be adjusting the height of me. So now in this example, I have 100 yards between each segment, 1 football field between each segment here. So 100 yards, 200 yards, 300 yards. You can see that 1 mil at 300 yards is a measurement adjustment at 100 yards of 3.6 inches. 1 mil adjustment at 200 yards is 7.2, or twice that amount. 1 mil adjustment at 300 yards is 3 times that amount, 10.8. And you can see down the line all the way up to 1,000 yards, we're at 1 full yard or 36 inches. And you just got to envision that there is 100 yards or 1 football field between each segment here. But this is to life scale of what 1 mil adjustment is. And that's really what makes this system so simple, is once you understand it, it doesn't matter if you're shooting in yards or meters. If you're shooting 1,000 meters, 1/1000 of 1,000 meters is 1 meter. So it quickly converts back and forth regardless if you're using meters or yards. Now, because these measurements are so big, that is why they're subdivided into tenths. You know, for a pure example, at 100 yards, it's 3.6 inches. If you make 1 mil adjustment, it transposes to 3.6 inches at 100 yards. And like, if you're new to the game and you are watching me make those mil adjustments in tenths, be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 full mil adjustment. Each click of that turret is 1/10 of 3.6 or 0.36. And you can see what I just did there. I just moved the decimal point over 1. If you remember that from your basic math days. But that is the beauty of this system. You know, for example, at 200 yards, 1 mil adjustment at 200 yards is 7.2 inches. Well, one click on that turret is, just move that decimal point over, 1.72 inches. At 300 yards, 1 mil adjustment at 300 yards is 10.8. Well, one click of that turret is going to be 1.08. You're just moving that decimal point over 1. Now, for pure example, say like I'm shooting at 300 yards and I'm shooting for the bullseye and I hit 3 inches low. Well, 1 mil adjustment at 300 yards is 10.8 inches. Well, each click or adjustment on this turret, you're going to divide that by 10. This is divided into tenths, so one click represents 1.08 inches. Well, if I shoot for my bullseye and I shoot 3 inches low, that means I need to come up 3/10 on my turret. And that's going to be roughly a little over 3 inches at 300 yards. Another pure example would be at 600 yards. Say I'm shooting for my bullseye at 600 yards and I shoot roughly 4 inches low. Well, you can see at 600 yards, it's 21.6 inches. It's just 3.6 times 6 is 21.6, and this is divided into tenths. Each click is going to be 2.16. You're just moving that decimal point over 1. And if I shoot 4 inches low, I'm going to make a 2/10 adjustment on my scope turret, and you're done. Now, like I mentioned previously, MOA-based scopes, if they're in quarter-minute adjustments, and if your mil-radian-based scope is in tenths, you can see that each click on that turret, on the MOA turret, is a little more fine in regards to the mil-based scope, which at 1,000 yards, 1/4 minute angle adjustment is going to adjust at 2.618 inches, and one click on the mil-based scope, which is 1/10, is going to be 3.6 inches. Most people can't shoot that difference. You're not that accurate, trust me. But if it is an issue and you think it's a concern, they do have mil-based scopes in not 0.1 but 0.05. You know, more times than not, when it comes to, you know, F class or bench rest rifle shooters, they're going to be using minute of angle scopes, and they like that fine adjustment, and a lot of them actually go all the way down to 1/8 minute of angle adjustment on their turrets. But it, once again, all comes back down to preference. So if I could give you some words of advice, some numbers you should really try and memorize, especially if you're going to go between these two systems, is for minute of angle at 100 yards, 1 minute of angle adjustment is 1.047 inches. And you can always times this number by how many yards you're trying to shoot. If you're trying to shoot 500 yards, you're simply going to times this number by 5 to get 5.235. And it doesn't matter if you're shooting at 550 yards. You're just going to take this number, 1.047, and times it by 5.5 to give you the amount of adjustment that 1 minute of angle will do at range. Same thing with a mil-based scope. Just remember at 100 yards, 1 mil adjustment is going to be 3.6 inches. You can always subdivide this by 1/10 or 0.1 to figure out how much each click is going to adjust at 100 yards. And if you want to figure out, for example, how much 1 mil is going to adjust at 500 yards, you're simply going to take 3.6 times 5 to get 18 inches. And you're going to redivide that 18 inches by tenths, just moving that decimal point over 1. Each click is going to adjust 1.8 inches. Now, another number that you're probably going to want to remember and lock into your head if you want to convert back and forth between mil and MOAs or MOAs to mil is there are 3.438 minutes of angle per mil. And I'm showing you in a life-size perspective of how that works. Remember, 1 minute of angle at 1,000 yards with a MOA-based scope is 10.47 inches. Well, you can see 1 mil of adjustment at 1,000 yards with a mil-based scope is 36 inches. I can put 3.438 of these units, mark this here, this is 2, 3, and I got a little bit further to go, and that's where that 0.438 comes from. And I can show you the math, and it's really simple. So with the mil-based reticle at 1,000 yards, 1 mil of adjustment is 36 inches. Well, remember, with a minute of angle, it's 10.47. Well, all I need to do to convert that is to simply take 36 inches and divide it by 10.47, which comes up to that number, 3.438 inches. And that's how you convert back and forth from minute of angle and mils. So regardless of what yardage you're shooting at, if you need to adjust 2 minutes of angle, it's just 2 minutes of angle. It's independent of what yardage you're shooting at. And if you need to convert, for pure example's sake, say I need to convert 1.3 mils to minute of angle, I'm simply going to take that 1.3, which is one full mil and 3/10 of another 1.3, and I am going to times that by 3.438, and you're going to easily convert that to minutes of angle, which is going to be 4.46. We're just going to round that up to 4.5, so that'd be 4.5 minutes of angle. And likewise, if I'm shooting and I'm using minutes of angle and I need to adjust 5 minutes of angle, but I want to adjust that back to mils, I'm going to divide that by 3.438, and it's going to be roughly 1.5 mils. So like I said earlier, there really is no difference between these two. It's just that the fact that you're using smaller blocks here, if you want me to symbolize that, with much larger blocks, and you're subdividing these smaller blocks by 4, and you're subdividing these much larger blocks by 10. So like I was saying earlier, if you want finer adjustments between these two, they do sell minute of angle based scopes that adjust in 1/8 rather than 1/4. You're just going to be adding another line between all these lines. And rather than subdividing, for example, the 700-yard block of 7.329 into quarters, you're going to be dividing that into 8ths. Same deal with the mil-based scopes. For pure example, they do sell mil-based scopes. Rather than adjusting in 0.1, they adjust in 0.05. So you're going to be adding another line between each one of these. And rather than dividing this entire block, for pure example, of 600 yards of 21.6, each click is going to adjust 2.16. You can get a scope that adjusts rather than 0.1, 0.05, and rather than each click adjusting 2.16 inches, mil-based scope that adjusts in 0.05, each click is going to be half of that. It's going to adjust in 1.08. And once you learn the method to the madness between these two systems, they're pretty much the same. It's just a different way of thinking about it. And after explaining all of that to you guys with a massive knowledge dump, I gotta admit, I think I got a headache. Well, I hope you enjoyed part 2 here on what and how to use a minute of angle and mil based scope, and slightly going over trajectories again. And stay tuned to part 3, where we're going to go over second versus first focal plane scopes and how to initially set up your firearm when you first mount that optic, and also what you need to do every single time you take a trip to the range and you pull the trigger. I'll see you next time.